How do you see if it's live actually?
Go to Hangouts.
Okay, we're live.
Yeah. Hello? Hello? Hello?
Not working.
Hello? Hello?
Not working.
Not working. Murphy. Hello? Hello?
Okay. Hello everyone. Welcome to our first show and tell session. So today's session is going to be presented by Juan Castillo, our fellow developer. And the whole point of this is that at Talos there is so many people who know about great new technologies or have very interesting topics to teach each one of us. So why settling down with the things that we work at every day? We also want to learn and be able to apply cool stuff and explore new paths. So let's welcome Juan Castillo, and he's going to be exposing service discovery using Consul and Docker.
Right. Thanks for coming. I see many familiar faces. So, all right. First of all, I wanna say that this is awesome. So, this is the first one, of course. But if any of you has like a topic you really like, please share it with us. Talos is giving you the opportunity to talk about those things you like. So, the next thing is that if you haven't seen this talk yet, is because you missed the first one at Medellin DevOps, and that's the local meetup to talk about DevOps and distributed applications. So please come with us. And the next talk is actually on February the 3rd, and we're going to talk about integrating Consul, Nomad, Docker on AWS. So it's going to be a great talk by very talented people. All right, so we're here to discuss service discovery by the power of Consul. So why this talk? So a few months ago, the previous project I was working on was probably gonna be ported to a microservices architecture, and I'm gonna explain a little bit what that meant. So we have like a monolithic application. That means that all the application's logic was in one single deployable executable, and so we started to think about components that we could isolate and deploy as autonomous services. And I was like, what? Like, so how we're gonna orchestrate all these modules and actually have like a reliable application. So I remember hearing about these services in another meetup, and I went to look for them, and they were actually like a pretty good option. So this is what we typically have. Sorry, I don't know if you can see very well. So okay, so anyway, here you have a service client, which is one that depends of many other services. So you have service A, B, and C, and how are you supposed to find them in your network or in your data centers? And that's a very tough problem that distributed applications are finding like in the past few years. So the first option, and it's not the best one, of course, is to just write the addresses of those services in your code, but that's going to be a very big problem very soon, because what if you redeploy them and they change IP, for example, or they're in another port than the one that's on your code. So they're not gonna be reachable. So we need to solve this. So this is actually a very good solution, and it's to have a service registry. So when you deploy a service and you run it, it actually makes a request to another service that serves like a dictionary. So it says like, hey, my name is I don't know, Michael, and this is where I'm at. This is my IP and this is my port. So if someone comes asking for me, just tell them I'm here. So along comes another service of that type. Sorry, of that type, and it's like, hey, I'm another Michael, so I'm at this other address and other port. So just hit me up if somebody needs me. And you can have a lot of services getting registered there, and then when another one needs one of them, he just asks the service registry, and he knows where they're at any moment. So there's actually a hope for us in the distributed applications world. We can forget about Mordor. So one of the first building blocks that we're going to need to actually achieve this is Docker. I don't know how many of you know what Docker is. Okay, great. So basically, Docker is like a container manager. So previously we had VMs to isolate processes or applications, but they're not very lightweight. They need to be managed by a hypervisor that we have here on top of a host operating system. So yeah, containers are a much more lightweight approach to isolate processes and have like memory allocated for them and other resources. And that's because they can share some of the underneath resources like operated DOS, libs, and beans. So as you can see here, we don't need to have like guest OSs for each process that we need to isolate. We can actually share the underneath resources. And it's actually not just a container manager, but it's actually a whole ecosystem. It makes some great tools like machine registry, swarm, and compose, so that it's easier for you to manage those containers and reuse images that are like the templates from which the containers are created from. All right, so this is general explanation of how Docker works. Basically, you have a client, and it's just like an interface to decouple your machine from the server, which is the Docker host or the daemon, and that's the component that does all the heavy lifting. It builds the containers from images or templates, if you will, which it pulls from the registry, which is a cloud service where you can upload your templates or images and use and take a look at the ones that are already there. So it makes it easier for us to deploy isolated processes, our services, without needing to configure too much our environment. So we can have like a container with Go, another with RabbitMQ and whatnot. So the other component is Consul, and that's what we're gonna be talking the most about today. And it's the service registry. It's where you go as a service to register and where other services come looking for you. And it's awesome. It's made by a company called HashiCorp, and they're all about distributed systems and applications, and they're making great tools to help you as a developer manage all those things. So it's got client registration, health checks, key value storage. It's highly available. it's distributed so you can run Consul as a cluster. So if one of your service registry is down, you also have like a redundancy. It's got a DNS interface to find all those addresses. It's also got an HTTP interface. It's got a graphic UI, a little nice web page where you can go and take a look at what's happening. It's data center aware, so you can actually ask for a service that's near a certain data center. For example, in the US, which is a very big country, you have a data center in the West and in the East, for example. So you can ask, hey, Consul, give me one of these services, which is called, I don't know, Michael, just to keep going along with that, which is near the East data center. So it gives you a lot of freedom, and well, it's awesome. So where does Consul go in our example here? And this is it. It's the service registry. And yeah, it sounds pretty simple, and it's actually pretty simple to use. And the other thing is a tool that Glider Labs, another company, built atop of Docker and Consul. It's called Registrator, and according to themselves, it automatically registers and deregisters services for any Docker container by inspecting containers as they come online. So it's basically a creeper. It's just taking a look at what's happening with the containers, and it automatically registers them and unregisters them from Consul. So we could say they work very well together, right?
Politically correct.
Yeah. So, okay, enough theory, and let's watch me fail. I mean, do the demo. So, hey, can you? Yeah, because I can't hold it when I'm typing. Thanks.
But you want to, yeah,
Okay, so I'm gonna move to this because that was.
Oh, sorry.
So the first thing we have to do is actually run the Docker servers or the daemon, and we do that by simply typing Docker daemon. Is that size okay? No, I don't think it is. Is that better?
Yeah.
Okay. So. Oh, that's fine. That's fine.
Are you the owner of this computer?
Of course I am. There we go. So there it is. Docker started, and on another terminal. Thanks. We're gonna run Consul, and actually I have a little cheat sheet right here, so I don't screw it up. So I'm gonna. It's already. Thanks. There we go. Okay, so I'm going to explain what it's doing here. And we're telling Docker to run a Consul container, right? So we're telling it to expose the 85. Oh, sorry. The 8500 port, also the 8600, which maps to the 53 UDP port on the Consul container, which is used internally by Consul to communicate within its cluster, right? So that's not very relevant for this talk. This is the name of the container that we're gonna run. These are actually some flags for the container. So Bootstrap you wouldn't actually use it in production because it's basically telling it to start with only one member of the cluster, which is not what we want in a production environment where we want redundancy in services, right? And we're gonna tell it to publish, if you will, our local host address and just show us what you're doing without the bug. Yeah, flag. Okay, so next up, we're gonna run registrator, which is gonna spy on Docker's API, which is a Linux socket. I mean, yeah.
Oh, it's a creeper.
Yeah, it's a creeper. So we're telling Docker to run a container with the name registrator.
Submit.
What?
Submit.
Oh, yeah. Okay, yeah. Here we go. We're telling the container where Docker's socket is, so that it can actually take a look at what's happening and do things like registering and deregistering unregistering. Thanks. You're a very versatile helper.
Okay.
Okay, and we're telling it to use this specific container to, well, I already pulled the image from Docker's hub because it's very slow sometimes. So for this doc, we're just gonna say it's there already, and we're telling it also where console is so that it knows where to call it actually. So oh, never mind. That's fine. Right, so there was another container with that name, so I removed it. And the only thing we're missing is actually like a service that we can register in console using registrator. So what's great, yeah, not yet. So what's great about registrator is that it decouples your service from console. Your service doesn't need to know where console is. It just boots up and it's magically, I quote that, registered in console. So let's take a look at what it does. It's just a very simple server written in Go. And basically, if you go to the root URL for the service, it's gonna call a function which tells who is visiting in the IP of the service. So I actually have a container for that. So we just have to run it. Here it is. We're gonna run it on port 6060, which maps to the port 8080 of the container, which is where the server is actually listening on. So let's just run that. That's actually running. So I can run more on a single terminal. Let's use the -d flag, which is to run it asynchronous. No, in parallel, detached. So there we go. It just returns an ID, and so if we go to there, we can see that I didn't. Oh, by the way, this is console's UI, which you can see is very nice. Here we can see our server container registered, and I didn't do anything else than just running the container. So that's pretty great, I think. And let's run another one. Just we're good measure. So if we reload this, we can see that there's two. Yeah.
Broken the directory. There's two there.
Back to all services, and here we can see that there's two passing because console actually checks for health. Yeah. Right. And if we go to our 6060 port, you can see that the service is actually running. So here's Johnny. All right. So and also if we actually stop one of the containers, we go to console's UI, we can see that, oh, sorry, there's just one now. So registrator actually unregistered that service. So that's all good right now, but maybe you're wondering, if I have a service, how do I ask console for that service's address or for the available services at any given time? So actually, it has a pretty great REST HTTP interface. So we're gonna use it. It has an endpoint to ask for a service. So if we just make a request for that and put with our required server's name, oh, what happened? Oh, of course.
Can you see that?
Yeah. There we go, that's better. I think it's, there we have it. We have an array with an object for each available service that responds to that name. In this case, server. It's telling us the IP address and also the port on which we can actually access it. Then the ID of that service within our console cluster. And well, that way you can, let's say you have a service in Spring or Rails, you can query console for a specific service, and according to that, the response, you can redirect your request to one of the addresses that console is telling you to. So that's it.
Awesome.
Yeah. Okay. Sure. Oh,
all right. So why is this relevant? Sorry, I think it's a little late for this, but actually, a lot of many of the biggest companies there are right now are using distributed systems or applications approach for their services. For example, a very famous example is Netflix. I don't know, they have like a bunch of services. I've seen like an image showing how they're deployed and how they're interconnected, and it's a web of weird stuff. So without these services like console, there's actually more Eureka, which is actually done by Netflix. There's ETCD, there's Zookeeper. They make doing all this stuff a lot easier, because otherwise you'd have to re-implement a lot of logic in every service that you deploy to try and find some other services. So that's pretty great. So does anyone have questions?
You have questions? about the magic that you talk about, the registry and the discover the service automatically. It only works when the Docker's containers inside the same Docker machines. For example, I want to register a service that don't depend of Docker in the same console, then you have to do another thing to register in that console instance, something like that.
Yeah, Registrator is meant to work with Consul and Docker. So if you don't have any of those, well, actually, I think there's like an adapter for different service registries. So there's one adapter for Docker. So I think you could actually make it work with any of the other ones. But it does have to work with Docker because it listens on that socket, which is where Docker establishes the connection between its server and the client to know when a new container is born or yeah, killed. Yeah.
Anybody else?
Can I run Docker inside another Docker?
Yeah, you can. Yeah, actually, I was checking Docker's contributing guide, and they actually have like a container to develop Docker. So you actually have to download that on your machine, run it, and get into it, and that's where you are supposed to develop to contribute to the Docker project. So that's kind of weird, but it's cool.
Anybody else?
No.
You'll want beers. All right, so finally, remember to join us for the DevOps meetup. Pretty talented people are going to be talking there, so make sure you join us. And these are some cool resources that you can check if you want to know more about the subject. And thanks.
Thank you.
Hey guys, one more thing. So you see, the whole point of this is sharing this cool stuff. He just introduced us to a modern issue in the industry, like what tools are available to address it. If any of you has any topic that you want to talk about, even in projects inside of Talos that you want to share something, a complex feature that you solved by using a cool library, I don't know, one of these tools that are coming up in the industry, come to us, come to the Tech Leads, and we'll help you get a space here to talk to us and share it with us. Thank you.
Awesome. Bien. ¿Cómo algo acá? Ya se acabó en inglés.